This lesson is about solving trig equations. An example of this is solving what looks like a quadratic trig equation. Now it sounds a little complicated, but really what we want to do is we want to treat this as we would any other equation, and really what we want to do is solve for x. Now x in this case is an angle, so our answer should look something like that in radian measure. The key word in this question is exact. Exact means do not use your calculator. You're looking at using the unit circle or some other method to help us find the answer. So to begin this question, we want to treat it like a regular equation. So I'm just going to rewrite it out. 2 sine squared x minus 1 is equal to 0. To solve for x really means to isolate for x. So right now I am moving the 1 across, or adding 1 to both sides, and then dividing both sides by 2. Now this next step is very important because we want to solve for x, and right now we have sine squared. So we understand from work that done in the past that to get rid of a squared we take the square root. So that is looking good on the left hand side, and on the right hand side we have a plus or minus 1 over the root of 2. Remember, the square root of 1 over the square root of 2 simplifies to the square root of 1 over 2. Now in terms of unit circle, this is very similar to plus or minus root 2 over 2 when we rationalize. And we recognize that this appears a number of times on our unit circle. The restriction that we're looking at in terms of domain is only one full revolution of the unit circle, from 0 to 2 pi. So really this question now becomes a two-part question. So part 1 is taking a look at the positive values. So when sine x is equal to root 2 over 2 positive. And then part 2 would be looking at when sine x is equal to negative root 2 over 2. If we approach these questions independently, we end up with a unit circle that has values for sine x equaling root 2 in quadrant 1. And if you think of the unit circle, the sine is always the y coordinate. And we also have another coordinate point that gives a positive sine value of root 2 over 2. These occur at pi over 4, which is this angle right here. And then we also have 3 pi over 4, which is approximately, or exactly, 135 degrees. So those numbers came directly from the unit circle. Those are two parts of our solution. But we also have a negative situation. So we redraw the unit circle once again, or look off of our sheet. And we also notice that sine x has a value of negative root 2 over 2 in quadrant 4, which gives us this entire standard angle, which is 7 pi over 4. And that also occurs in quadrant 3, where we have another coordinate point of negative root 2 over 2. And that occurs at 5 pi over 4. So in total, x can be equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. The next question we're looking at is a similar type, but we're looking at solving a trig equation by factoring. Now some of you may choose to use the pseudo technique where a is equal to cos of x, and we can rewrite the above quadratic as a squared minus a subtract 2, and then apply our basic factoring. Once that factoring is done, we can remove ourselves from the pseudo technique and rewrite it as cos of x minus 2 and cos of x plus 1. And just like any equation, if we're solving for x, we want to take each binomial and set it equal to 0. So once again we have two possible cases, but we see very quickly when we move the 2 to the other side or add 2 to both sides, the question is, when does the value of cos x equals 2? And without looking at the unit circle, we could just do a quick sketch of the cosine curve. There it is. And note that the highest point it ever gets to is 1. So the cos x curve never actually gets to a value of 2. So this particular situation there are no solutions for. So we can focus our attention on the second equation and ask ourselves, when does the value of cos x equal -1? Well, again, we're going to turn and look at the unit circle. And when we look at the unit circle, remember that coordinate points, cos is the first value, sine is the second value. Well, really, where is the x value -1? Well, that occurs right here at -1 and 0. This is the cos value, and therefore the only answer we have between 0 and 2 pi. Therefore, the only answer we need between 0 and 2 pi is x is equal to pi, or 180 degrees. The next question we're looking at is a similar one, but we're dealing with reciprocal equations. So once again, we're going to let a equal cosecant of x and rewrite the equation as 2a squared plus a minus 1. Now we have to do a little bit more in-depth factoring, but if we recall that trial and error method, I'm going to take the factors of the first term and the factors of the last term and do some cross multiplication here. When I multiply 2 times 1, if I make that a positive, I get a positive 2, and when I cross multiply here and make that a negative, because this one sign has to be positive, one sign has to be negative, I end up with -1, and when I add them together, I get the sought after plus 1 out in front. So this tells me that my factors are 2a minus 1 and a plus 1. 2a minus 1 and a plus 1. Again, getting out of pseudo technique, we rewrite the question, and I'm going to set it automatically equal to 0. And then the second scenario is cos x plus 1 is equal to 0. So I've skipped a step in there, but you can go back and take a look at the last example of how to get from here to here. Finally, we want to try and solve this, so we start to move things to the other side, and I have cosecant x equals a half. Now you can stop here and you can think about graphically, what does the cosecant graph look like? Well, a quick sketch of cosecant, if you remember, is 1 over sine. And when I'm sketching that, I actually want to graph the sine curve very quickly here and recognize that there are vertical asymptotes everywhere that there is a 0. And the cosecant curve takes place at the max points and min points. And so the graph in red here actually never gets to a half. That's reserved for sine. So there's no solution to this at all. Cosecant x never gets to 1/2. If I miss that part and I want to rewrite this as a sine expression, and I rearrange the equation, that translates to sine x equals 2. And for the same purpose, we can see that sine x never actually gets to 2. So there is no solution to this part of the question. So now we can focus back on the second part, and that is setting cos x equal to -1. And a lot of students find it easier to rewrite this in terms of sine. And so what we want to do is we want to take 1 over sine x, set it equal to -1, and then rewrite the equation in terms of sine x. And sine x does equal -1. Remember that that is going to be the second coordinate point, and that occurs right down at the bottom if we look at the unit circle. And we have 0 and -1, and that is our sine value. So in this particular case, x is only equal to 3 pi over 2. And that concludes solving trig equations.